Hello my dear friend, in this video I will discuss PG semester 4 2020 question paper. So let us start video. First question, the quanta of vibrational energy in a periodic solid known is a photon array. So Bosch-Einstein statistics. Question number B here. If there are atoms in a primitive cells of a 3D crystal, then the number of optical branches will be minus 3r minus 3. And question number C, the average energy of neutron that have reaches thermal equilibriums with the atom of an moderating material at temperature T is nearly equals to 3/2 kVt. This is the correct option. Question number D, inelastic coherent neutron scattering leads to correct option is 1, information about dispersion relation. Question number E, incoherent neutron scattering due to both A1 and 2 is correct. And question number F, Hartree-Fock method is all of these. And question number F is here. Wait up. Question number F, Hartree-Fock method, all of these, and B is correct. And option number G, the bandwidth S band of FCC cubic lattice is tight binding approximation is equals to 20 V. And question number H, Hartree-Fock Hamiltonian is Hermitian in nature. Question number I, in the Haas-Van Alphen effect, the oscillation occur at equilibrium interval of 1 by b, where delta 1 by b is equals to this 2 pi e h cut cs. So next question is that question number J, the magnetic moment in a metallic gold having the period of 2 × 10⁹ Gauss per unit corresponds to an external area. Option 1 is correct, 4.8 × 10⁻16 centimeter square. Group B, answer the following. Obtain expression for angular force in a 3-dimensional lattice vibration. Question number B, obtain Hamiltonian for 3-dimensional lattice vibration. Question number C, what is catch 22 situation of Hartree-Fock IPA? How is this broken? Question number D, write down an algorithm for HF SCF. Question number E, what is tight bending approximation? And question number F, find the bandwidth S band of a SC lattice in the term of overlap integral in tight binding approximate. Question number Z, explain brief the Haas-Van Alphen effect. And group C, discuss the quantization of lattice vibration in 3 dimensions. Thus show the vibration of any atoms is equilibrium position can be resolved into normal mode. Question number 4, obtain expression for differential scattering cross sectional of incoherent elastic scattering of neutrons. Question number 5, derive the HF's equation in the diagonals from Phonon orbital approximation. Question number 6, state and prove Bloch's theorem. Question number 7, obtain the S-band dispersion relation by using tight binding approximations. And the last question is here, construct the Fermi surface of metal on basis of free electron models and define density of a state. So this video is semester 4 Munger University. So I hope this video is useful for your coming examination. Thank you for watching this video.